Hello, everyone. My name is Branch. I'm calling in from the Outer Banks of North Carolina. Normally, I'm in Raleigh, but visiting some family. Actually, behind me, I have some Wright Brothers Memorial um, commemorating the first flight, which was on the Outer Banks of North Carolina. Let me share my screen. Awesome. So today I'm going to cover for you basically a little journey through kind of developing an autoscaling IoT pipeline based and deployed on Kubernetes. So before we get started, a little bit about me. I'm a backend engineer at a startup company called Industrial.io. Also, I'm really passionate about open source, and you can find me in the open source world contributing to Homebrew as one of the maintainers. And I'm on GitHub with my name at Branch Vincent, so you can follow me there. And a little bit about my company called Industrial.io. It's an IoT startup in Raleigh, North Carolina. We ingest and analyze sensor data with a goal to help industrial factories optimize their energy consumption. So trying to help make the world a bit greener through using less energy. So this talk, I'm kind of walk you through one of our projects that we completed where we had to develop and test and ship a new IoT pipeline to kind of combat some of the problems and challenges we were facing without it. So kind of the two key challenges for the project. One was that we at Industrial had really standardized on Kubernetes as our container orchestrator. And our data pipeline was kind of the last component that we didn't have on Kubernetes. And we really wanted to bring it over. And the second thing, while we were doing that and kind of rethinking kind of the stack, we also had kind of a frequent issue where we had some unpredictable load coming from these sensors that we're ingesting data from. And that occasionally caused a backlog in our processing queues, which meant that customers had to wait to see some of the data and electricity data that they were used to seeing in real time. So we wanted to see if we could kind of address that. So briefly, kind of like the overview of what we ended up going with was basically using a technology for messaging called Pulsar, as well as throwing everything into a time series database known as Timescale. And Timescale is a Postgres extension. At Industrial, we had already standardized on Postgres. And so a Postgres extension made a lot of sense for us. And also you can see kind of our pipeline architecture was really based on just at the core, the concept of containers and pods in the Kubernetes world. So each step in our pipeline was just simply a container. And we did that so that we could have ephemeral pipelines or steps in our pipeline, so we could spin them up and scale them down dynamically to kind of address our dynamic load. And so I'm kind of walk you through how we did it with a focus on, of course, that Docker was right there with us the whole time. So kind of first thing, with the stack that we had, we wanted to make sure that we could run it locally without any issues. So of course, Docker Compose was a natural fit for us. And for example, here I'm showing kind of our timescale database as part of our Compose stack. We really use the concept of volume binds here. So in the Postgres container image, it'll run anything mapped to this Docker entry point, and we use that to initialize and seed our database, as well as health checks was really important for us. So health checks is a concept to basically define if your container is healthy. So by default, Docker will start your containers for you, and it knows that it's running, but it may not know if it's available yet. So for example, for a database, even if the container is running, the database might not be initialized yet. And we wanted to make sure that we could spin up our stack and kind of be ready to go as soon as we were able to guarantee the health of the containers. And so health checks made that really easy for us. Another thing that we used as part of Compose is controlling the startup order with the depends clause. So we had our database depend on our Redis cache as well as our Pulsar messaging queue. So we could ensure that our database wasn't started until these other containers had started and were also healthy. So I just want to show really quick an example. Let me clear all this out. So I had this running. Let me spin this down. While that's waiting, just show our Compose stack again. So we have our database, which is kind of where all of our data is ending up. We have Pulsar as our message queue. We have a Redis cache. And we also kind of have a separate test container. The difference here was that we basically didn't have a volume mount. So we weren't persisting data between restarts of this container because for testing, we didn't want that. We wanted, a clean slate every time. And so we kind of had a different container for that. And this is having trouble coming down. So let's just pop here and remove them here. Let's see. Interesting. Okay, well, let's ignore that. But one thing I wanted to show you, which was really important to us, let me remove these dependencies. I'll use my DB test container instead. But the concept of health checks. So Previously, we could spin up our container, and it will return as soon as the container is running, but not necessarily when it's healthy. So that has implications in maybe testing. If you want to query your database right away, you need something to basically check that the container is healthy. And we really wanted Docker to do that. And actually, recently, they've introduced the ability to, which is great. And I'm not sure what's going on. Let me restart Docker Desktop. And if that doesn't do it, we can move on. Okay, there we go. I'm not sure what was happening, but that's okay. So going back to our example, if we spin up, our DB container, we have a health check, but we really wanted to block the container until it was healthy as declared by our health check. And so I missed it. I wanted to show you really quick. So if I spin this up, it returns, but it may not be healthy yet. See, it's still starting. And now it's healthy. So before, what we were doing was basically, after spinning up our stack, we had a custom script to basically pull the health status of each container to block until our tests were able to run like in a testing environment. But now, Docker Compose actually integrated this feature into the CLI in the form of a --wait flag. So if you pass --wait, now your stack will block until everything is classified as healthy. And so we can see as soon as I run and check on our containers, it's healthy. So this was a really great feature for us and something that allowed us to get rid of like some custom scripts that we had. So that was great. So our database is up. I was just going to show that we already have an initialized schema. So if I do this port correctly, and I spelled the database wrong. So we can see we already have tables initialized with some seed data. And that was coming from our volume mount here that we have declaring our SQL. So this is a feature of the Postgres container looking in that directory for any SQL scripts to run. So you can use that as a way to migrate your database on startup without needing a separate database migration tool. So that's how we managed our stack locally in development. And then moving on to our testing environment. Our testing was really, really simple with GitHub Actions. It was actually no difference than running our stack locally in development. That's because GitHub Actions allows you to very easily run Docker without any any configuration. So for example, here we're spinning up the stack. We're actually utilizing this -- wait flag. So as soon as this returns, we know that our database is ready, and we can go ahead and run integration tests against that database. And so that was really all we really needed to do in testing. Again, because we were using the same exact compose stack that we were using locally, we could reuse it in GitHub Actions. And then kind of moving on from testing and kind of shipping our stack to production, what we basically use as our orchestrator, like I was saying, is Kubernetes. We use a tool called Helm to help install our resources. And going back to one thing that we really wanted to accomplish with this project was kind of dynamically scaling out each step in our pipeline. We were able to use that with a feature of Kubernetes called the Horizontal Pod Autoscaler. By default, you can autoscale based on some out-of-the-box metrics that Kubernetes is already watching for you, such as we can see here, CPU is a metric that you get out of the box. You can also autoscale based on memory. So if you have one container and you've configured it to have an average utilization of 50%, if it starts targeting 100%, then Kubernetes will spin up an additional container for you. So this was close to what we wanted, but we didn't want to scale on CPU or memory. We really wanted to scale based on how many data points were waiting in the backlog of each step in our pipeline. So going back to kind of this pipeline, what it looked like in reality, everything in this blue box was installed with Helm as our package manager. And each step itself was a container. And so what we were able to do is using HPA, each one of these steps we're able to scale horizontally, automatically, based on how many messages we're waiting in the backlog for every step. So what does that look like exactly? How do you set that up? So again, each step was able to be horizontally scaled. The autoscaler for Kubernetes uses some basic algorithm to compute how many desired pods based on the current state of whatever metric you decide to autoscale off of. And the only complexity really was for us to figure out how we could get basically the metric we wanted to scale off of into Kubernetes and make it aware of it. And so, like I said, CPU and memory are available out of the box. If you want to use something different, Kubernetes allows it because it has great extensibility, but you need to use and configure basically an external metrics server to provide the metrics that you want to scale off of. And so we kind of thought that that would be the most challenging part and that we would have to roll our own metric server. But actually, we were already using Datadog for logs and other analytics. And actually, Datadog was able to serve as our custom metric server. And Datadog was already scraping our Pulsar metrics. So really what it came down to was configuring only a few custom resources to get our autoscaler aware of how many data points we're waiting in the backlog. So on the left here, actually I'll start on the right. All we needed to declare was basically a Datadog query that described the metric that we wanted to scale based off of. And then on the left here, we basically just plugged in this query into Kubernetes HPA. So we were able to say, for this pipeline step named pipeline step name, we want you to have a target of 5,000 data points in the backlog. And for Kubernetes to know the current value of the backlog, use this custom resource of this name, which is being provided by Datadog. So with these two resources, we were able to get autoscaling out of the box on Kubernetes. And so that was a very beautiful realization of how easy it would be. And then I just kind of wanted to show the outcome of all this work. This is a Datadog dashboard, actually, displaying some stats of our pipeline. And this is actually showing the HPA in action on 1 a.m. While everyone was sleeping. So we can see we got a backlog basically of 500,000 data points waiting to be processed. And we can see here on the bottom right, what happened was you can see this blue line is our metric that we were scaling off of. You can see it ramping up, and you can see the blue line is the number of pods. And so it's scaling and ramping up along with the metric as expected. And then, once we had more workers working through all this data, we got through the backlog, and so we were able to scale back down. And so this all happened by Kubernetes. And so this was great for us. And again, containers and Docker was really at the core here because we were able to scale horizontally because everything was a container. It was stateless. All of our state was stored in other services. And so every step in our pipeline was ephemeral and could just come up and spin back down at will. And so that was just a quick overview of that project and how Docker really enabled development and how testing was really, really the same for us because of our Docker Compose stack and because of GitHub Actions. So I just wanted to give a shout out to everyone at Industrial. Special shout out to Michael, who is one of the close co-workers working on this project with me. And also Industrial is hiring. So if you're interested in IoT and you like kind of the technology that we're using, feel free to see open positions at industrial.io. And thank you everyone for coming, and I hope you enjoy the rest of the day.